In this video, we're going to practice all the concepts together, and we're going to find all zeros of a polynomial function. Now, what it means by all zeros is that we need to find all the real zeros and all of the imaginary zeros. And so this takes all of the concepts into consideration. So here we have the polynomial 4x to the fourth minus 13x cubed minus 13x squared plus 28x minus 6. First thing we're going to do is if we want to find all of our zeros is we need to find what are our possibilities. So the first thing we want to do is we want to find our possible real zeros, which that is your P over Q list. So here P is 6. So we want all the factors of 6, which are plus or minus 1, 2, 3, and 6. And Q is our leading coefficient of 4. And so we want all of the factors of 4, which is plus or minus 1, 2, and 4. So the list, the P over Q list, our possibilities are the following. Remember, each value in P must be divided by every Q. So we got 1 divided by 1, 2 divided by 1, 3, and 6 divided by 1. So that's plus or minus 1, 2, 3, and 6. We have 1 divided by 2, which is 1/2. When we take 2 and divide by 2, that's 1. When we take 3 and divide by 2, that's 3/2. When we take 6 and divide by 2, that's 3. Already there. So we have 1/4 next. 2/4 is 1/2. Then we have 3/4. And we have 6/4, which is 3/2, which is already accounted for. And so our possible rational zeros are plus or minus 1, 2, 3, 6, 1/2, 3/2, 1/4, and 3/4. Now what we're going to do is the same thing as we did before. We are going to input this list into our calculator. And so let's input it in the calculator. So we get our graphing calculator out. And so we're going to input our polynomial into our y equals. So we have 4x to the fourth minus 13x to the third minus 13x squared plus 28x minus 6. And so I input my polynomial into the y equals. Remember, we go to our table, second table. We've already in previous videos changed our table setup so that it asks us for our own x values. We input our own instead of it creating a list automatically. So I still have values from my previous examples. So I'm going to hit delete to clear all of these out. And now I'm going to input all my possibles. And I'm going to remember if I do 1, I have to do -1 as well. And so 2 and -2. I have 3 and -3. And I'll just stop there, grab it, bring it down. Remember, now look at it, and we can see we do have a 0 at x equals 1. And so here is one of my zeros. And so now let's input the rest. So we stopped at -3. And so now I'm going to go back up. I'll just write over the other ones. I have 6 and -6. I have 1/2 and -1/2. I have 3/2 and -3/2. And I'll just stop there. If I take a look, none of those show a y value of 0, so none of those are my zeros. So now I'm on 1/4. So let's go all the way up. So we have 1/4. So we have -1/4 as well. and we have 3/4 and negative 3/4. And I'm going to delete the other ones. So I grab my list, bring it down. I see I have another 0 as well at x equals 0.25, which is 1/4. So my rational zeros, are x equals 1 and 1/4. But I don't just want my rational. I want all of them, all the real, all the imaginary. So the question is, how do you find the remaining zeros? And we have to go back through what we've done this whole unit so far. Is if we want to find our remaining zeros, and we already know a couple of them, what we do is we set up synthetic division. So we do synthetic division with our given zeros, the ones that we found. If we do synthetic division with our zeros, we'll get a factor that remains, and we can figure out what to do from there with it. So let's start synthetic division. We have 2 zeros, so we're going to have to do it twice. Let's start it with x equals 1. So we set 1 in our box. We're going to write down all of our coefficients that we had. And so we have 4. We have negative 13. And we have another negative 13. We have 28 and negative 6. Now we know x equals 1 is a 0. And we learned that means our remainder should be 0 when we do synthetic division. So let's drop down the first one. 1 times 4 is 4. Negative 13 plus 4 is negative 9. 1 times negative 9 is negative 9. Negative 13 and negative 9 is negative 22. 1 times negative 22 is negative 22. 28 plus negative 22 is 6. 1 times 6 is 6. Negative 6 plus 6 is 0. And so that works out. My synthetic division is perfect. Now what I'm going to do is this represents another polynomial. I did synthetic division with x equals 1. This is what remains. What I'm going to do here is synthetic division again, and this time with 1/4, using these as my coefficients. So I'm just, instead of writing it all over again, I'm just going to set up synthetic division right here. And so 1/4 is what I'm going to divide by. Now this is where my remainder box would go. 4 drops down. 1/4 of 4 is 1. Negative 9 plus 1 is negative 8. 1/4 of negative 8 is negative 2. And negative 22 plus negative 2 is negative 24. And 1/4 of negative 24 is negative 6. And you get a remainder of 0, which is good because I know 1/4 is a solution. So for negative 8 and negative 24 means 4x squared minus 8x minus 24. And so this is the factor that remains. And somewhere in here are the remaining zeros. So I see it's a quadratic. So what I'm going to do is I'm going to set this up for the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I don't know if it's factorable as is, so I'm just going to plug it in the quadratic formula. My b is negative 8. So the negative and negative is a positive. You have plus or minus the square root of b squared, so negative 8 squared, minus 4 times a, which a is 4, times c, which is negative 24. So 4 times a, which is 4, and c is negative 24, all over 2a, which is 4. And so then we do the math. We have negative 8 squared, I know is 64. And I have 4 times 4 times negative 24. So I have 4 times negative 24. And that is going to give me 384. And since I have two negatives there, it's going to be a positive. So I have plus 384. And then twice a is 8. So I have 8 plus or minus the square root of 64 plus 384, which is 448 over 8. What do we always do to our radicals is we simplify. And so I have to simplify 448. I know that 4 goes into there 112 times. I know 4 goes into 112 28 times. 4 goes into 28 7 times. And so if we look, 4 and 4 can break down into 2 and 2. Here's one set of 2's, here's two set of 2's, and a third set of 2's. So I can pull out 3 2. So 2 times 2 times 2 is I can pull out an 8. And so I have x equals 8 plus or minus 8 square root. 7 remains inside over 8. And divide everything by 8. X equals 1 plus or minus the square root of 7. And that is the remaining zeros. So what are all the zeros? All the zeros are the ones that we found with our calculator, which were x equals 1 and 1/4. And we also found 1 plus or minus the square root of 7 with the quadratic formula. We had originally a 4th degree polynomial. And so the fundamental theorem of algebra tells us the number of answers should be the same as the degrees. So I have 1, 2, a plus or minus 3, and 4. So I have 4 answers with a 4th degree. So this video was to outline every concept so far in chapter 6. How to find the possible zeros, how to find from there with our calculator which ones are actual rational zeros, performing synthetic division with those zeros to find the remaining factor, and then using a technique, either factor into the quadratic formula to find what the remaining solutions are, and then putting it all together to get all zeros.